You know, in the world of DevOps, speed is everything. We all want to go faster. But what if that speed is leaving the back door wide open? In this explainer, we're going to architect pipelines that are not just fast, but also secure by embedding quality and safety right into the process from the very beginning.
So, your code is shipping at an incredible pace, right? Deployments are happening multiple times a day, and that feels like a huge win for agility. But let's ask a tough question. In that rush to deliver, what vulnerabilities might be hitching a ride, flying straight into production along with your awesome new features? And this leads us to a really common scenario, the high-speed, high-risk pipeline. The pressure to deliver is just immense, and let's be honest, security and quality checks are often seen as annoying bottlenecks, so they get pushed way down the line, or even worse, skipped entirely. And what that does is create this hidden layer of risk that just builds up with every single commit. So the solution here requires a bit of a paradigm shift. You've probably heard the term shift left. Well, this is what it's all about. It means we stop treating security as a final inspection at the end of the process, and instead we pull those critical checks forward, embedding them directly into the pipeline itself. It becomes an integral, automated part of development. And the tool we use for this job is the Quality Gate. Let's get crystal clear on what this is, because it's important. It's an automated, non-negotiable checkpoint. It's there to enforce a specific standard, and if the code doesn't meet that bar, boom, the pipeline stops, dead in its tracks, no exceptions. It's basically your pipeline's automated conscience. Okay, so how do we actually build this? Let's dive into the architecture. It's not about finding one single magical check that solves everything. It's about building a layered defense, with different gates protecting against different threats at various stages of the pipeline. Let's break down the 4 essential layers of our defense. First up, static analysis, or SAST. This scans your own source code for common security flaws, catching things like SQL injection before they even get compiled. Next, we have software composition analysis, or SCA. This tackles a huge modern risk by checking all your open source libraries and dependencies for known vulnerabilities. Third, container scanning. This goes a layer deeper, inspecting the actual operating system and packages inside your container images for security holes. And finally, IAC policy checks. This makes sure your infrastructure code, like your Terraform or Bicep, is configured securely from the start, preventing misconfigurations before they ever hit the cloud. See, together, these gates cover the entire stack, from your code all the way to the cloud.
Now, theory is great and all, but let's see how this actually works in the real world. We're going to walk through a quick case study to see what happens when one of these gates slams shut and just says no to a deployment.
Okay, picture this. A developer has just merged a new feature. The CI/CD pipeline kicks off automatically. All the unit tests pass, the code is built, the container image gets created, everything is looking great. The final step, deployment to production, is initiated. And then this, a hard stop. The pipeline fails, the deployment is blocked before it ever even gets close to a production environment. Now, for the developer, yeah, this might be a little frustrating for a moment, but for the organization, this is a massive win. But why? Well, look at the quality of this failure message. This is not some vague error code 500, it's super specific and it's actionable. It tells the developer exactly what the problem is, a critical vulnerability. It tells them where it is in the base container image, and it tells them how to start fixing it. Check the scan results for details. This is the kind of high-quality feedback that transforms security from a roadblock into a puzzle that can actually be solved. And that clear signal is what turns a potential crisis into just a routine fix. The team can now move from a red alert straight to a green light without any panic because the path forward is perfectly clear. So the process is just incredibly efficient. The developer gets an instant notification. That error message, like we saw, tells them exactly where to look. They don't have to go hunting for the problem. They just need to act. So in this case, they simply update the Docker file to a newer, patched base image, commit the change, and poof, the pipeline runs again. Problem solved. And this comparison just illustrates the value perfectly. I mean, think about it. Without these gates, this exact same vulnerability might have been discovered weeks, maybe even months later, by a security team, or even worse, by an attacker. That leads to emergency patches, stressful meetings, and potential downtime. With gates, the vulnerability is found and fixed by the person who's closest to the code, in minutes, before it ever becomes a real threat. And this really brings us to the most powerful concept at play here, which is fast feedback. Shifting left is really all about shortening the time between when a defect is introduced and when it's discovered. In our little case study, the entire cycle, from the initial commit to the failure, the fix, and the recommit took less than 10 minutes. That right there is the power of a well-architected, secure pipeline. You're not just stopping bad code from getting out, you're enabling your developers to fix it immediately while the context is still fresh in their minds.
So let's wrap all this up with a clear, actionable takeaway. What is the absolute baseline set of gates that every single one of your production-bound pipelines should have?
All right, here are the essentials. First, you need to mandate static analysis, or SAST, for all your own code, and software composition analysis, SCA, for all your third-party dependencies. Next, implement robust container vulnerability and compliance scanning on every single build. And definitely enforce IAC policy validation to secure your infrastructure as code. And finally, and this one is critical, you absolutely must have a documented process for what to do when a gate fails. Because a powerful tool without a clear process is just noise.
By putting these gates in place, you've built a pipeline that isn't just a conveyor belt for code anymore. It's now an active guardian of its quality and its security. So your pipeline is secure. But as threats continue to evolve, the real question becomes, is it smart enough for what's next?